Example 2.3.5b, an electrical load operates at 120 volts RMS and absorbs 8 kilowatts at a lagging power factor of 0.9. Find the complex power absorbed by the load and the impedance of the load. So we were given that the RMS voltage is 120, angle 0. We know that the power is 8 kilowatts. We know that the power factor is 0.9 lagging. We were asked to find complex power and total circuit impedance. Okay. The solution to this, like so many problems in power engineering, really is probably most easily solved by drawing a power triangle. If we draw the power triangle, we know that the base of the power triangle represents P, the height of the power triangle represents Q, and the hypotenuse of the power triangle represents S, real power, reactive power, apparent power, watts, vars, voltamps. This is for a inductive circuit, and we know that in an inductive circuit, current lags. So this is the one we're dealing with in this problem statement here. There's another power triangle for capacitors, and it looks like that, and we know that in capacitors, current leads. So this would be for a leading circuit. So when you read that the current is lagging, you know that's inductive, you know that this is the power triangle you're dealing with. So we were given P in this, it's 8 kilowatts. We were asked to determine the complex power. So we need to know, what is the what's the magnitude of this vector, and then what's this angle right here? So we're going to use the definition of power factor to do that. Sorry, I'm touching all sorts of extra buttons on the laptop today. We're going to use the power factor to do that. We know that the power factor by definition is the ratio of real power to apparent power. And so we know that 0.9 is equal to 8 kilowatts divided by S voltamps. And so we get an answer. We just need to divide 8 by 0.9, and we get 8,888.9 voltamps is the apparent power absorbed by the load. That doesn't fully describe this system. We would like to know what the angle is. The easiest way to determine the angle is not by going to Google. The easiest way to determine the angle is to take the inverse cosine of the power factor. And so we take the inverse cosine of 0.9, and we get an angle of 25.84 degrees. That gives us a complex power of 8,888.9 at an angle of 25.84 degrees voltamps. So that's the total complex power. We could, if we want, use that geometry to go ahead and determine Q, but it's not asked for in the problem statement. What was asked was what's the impedance of the load. So we know that we've got some sort of load Z here, and we know that the supply voltage given to that load is 120 volts, and we know that it absorbs this power. So how do we get from here to here? We're going to use one of our power identities, and then that is that Z is equal to the magnitude of the voltage squared divided by the complex conjugate of the apparent power. So that's 120 squared divided by 8,888.9 at an angle of negative 25.84. And That's going to give me 1.62 at an angle of 25.84 degrees. And that's an impedance, so it's in ohms. And if I want to write that in rectangular form so I know how much is resistance and how much is reactance, I get 1.458 ohms of resistance, and I get plus J 0.706 ohms of inductive reactance right there. And I know that's got to be inductive because S was positive in that calculation. So there's the two answers.